Hi everyone, you are welcome to my YouTube channel on the Guru Brainstorm. My name still remains Mr. George Solomon, aka the Guru Master. Wherever you are at your comfort zone, please do well to follow me in this video as you subscribe and as well share to your loved ones. Now, in our previous lesson, we were able to learn about fundamental quantities, and in that lesson, we were able to understand that fundamental and derived quantities are all branches of physical quantities. And in that lesson, fundamental quantities are those quantities that are independent of other quantities, and they can also be referred to as basic quantities. And those fundamental quantities are those quantities that other quantities rely upon, and other quantities that rely upon are derived quantities. And in today's video, we are going to talk about derived quantities. Now, looking at the board, you see that the topic is derived quantities. Now, by definition, derived quantities are the quantities which are derived from the fundamental or basic quantities. Fundamental quantities can be referred to as basic quantities. That's why I see in bracket I wrote basic quantities through multiplication or division. All those examples of fundamental quantities we learned in our previous lessons, we can help us to actually obtain our derived quantities, which we are going to see by God's grace in today's video. Now, the units of derived quantities are called derived units. And these derived units are actually derived from fundamental unit as well. Derived unit depend on fundamental units, while derived quantities rely on fundamental quantities. So, examples of derived quantities and their respective units are: 1. We have area. And as we all know, in plane shape mathematics, area is length times breadth. And this breadth can be expressed in terms of length. So if breadth is expressed in terms of length, it means that the unit of length, of course, as we know in our previous lesson, is meter. So meter times breadth expressed in terms of length, meter. So we have m square. So the unit of area is square meter. Now, the next example is volume. Volume can be expressed as area times height. And already we have gotten our area as square meter. So we have this times height is also expressed in terms of length. So we have meter. When you apply law of indices here as well, we have the power of 1. So we have m to the power of 2 plus 1. So we have m to the power of 3. That's cubic meter. The derived unit of volume is cubic meter. So when you go further to other examples like speed or velocity, speed or velocity is displacement, or since I'm saying speed stroke velocity or speed or velocity, speed will, of course, we know is a derived quantity, while velocity is a fundamental quantity. And also speed is a derived a scalar quantity. Velocity is also a vector quantity. So they are two different things entirely. So in that case, we know that scalar quantities have only magnitude. So we can express speed as distance, while velocity, since it's a vector quantity, we can express it as displacement over time. So both distance and displacement can be expressed in terms of length, and the fundamental unit of length in our previous lesson is meter, and time is also a fundamental quantity. And in that lesson, we are made to understand that time is expressed in seconds. So meter over s. This meter over s can be represented as m times s to the power of 1. Is the same thing. So this is the unit of speed or velocity. So you can see that though speed is a scalar quantity and velocity is a vector quantity, but they have the same unit. That is the similarity, one of the similarities. They have the same unit. So the fourth example is acceleration. Acceleration is velocity with respect to time. And if acceleration is expressed as velocity upon time, then it means that velocity, of course, we have already seen that velocity is meter over s. So we can express it as m over s, then time s, which is the same thing as m over s times 1 over s. So once we apply the mathematics, mass times meter times 1 is meter, s times s is square, which is also expressed as meter times s to the power of minus 2. So either expressed in terms of this or in terms of this is the same thing. So the fifth example which I consider is force. Force. What is force? Force is equals to mass times acceleration. Mass times acceleration. And of course, you know, mass is a fundamental quantity. Fundamental quantity which is expressed in kilogram. And acceleration, we can see in example 4, the unit is meter per square second. So we have m over s square. So when you do the mathematics, kilogram times m is kilogram meter upon s square, which is also the same thing as kilogram meter times s to the power of minus 2. Either you make use of this or this is the same thing. Now the sixth example which I consider is density. Density. What is density? Density is mass over volume. Mass upon volume. Now what is the fundamental unit of mass? Is kilogram upon volume. You can see from the lesson number 2, volume. The derived unit of volume is cubic meter. So cubic meter or kilogram times meter to the power of 3. So either you go with this or this is the same thing. So let's consider other examples. What is power? Or better still, momentum. Let's consider momentum. Momentum is equals to mass times velocity. Mass times velocity. What is the fundamental unit of mass? Because mass is a fundamental quantity. Of course, we know it's kilogram times velocity, which is a derived quantity, is expressed as meter upon s, which is the same thing as kilogram times meter is kilogram meter over s, or kilogram meter times s to the power minus 1. Now, lastly, I want us to look at pressure. Pressure can be expressed as force upon area. And of course, what is force? We just derive force. The unit of force can be seen in example 5 as kilogram meter per second square. So we have kilogram meter per second square upon area. Area is cubic meter. Or now looking at this now, this can be reduced. This can reduce this to 2. So if this is reducing this to the power of 2, then it means that we have kilogram times s to the power of 2 over square meter, or it can be expressed as kilogram per meter square times second per square. So this is the unit. So far, I want to encourage you to still go through the video. It's very interesting. Just all what you need to do is to subscribe and share this video and go over and over again. with the help of God, you understand it better. Thank you for watching. God bless you.